So before we start with our first word problem, let us try to recollect the important points you need to remember from tool 1 and tool 2. So first thing what you need to remember is this front view is always a dash b dash and makes an angle alpha with xy. Top view is always denoted by AB and makes angle beta with xy. This true length with a dash a dash b1 dash is in the front view and it makes theta with HP always. And the top view of the true length AB2 is always seen from the top view and makes angle phi with the vertical plane. So theta is with HP, phi is with VP, alpha and beta is with xy. Another name for front view is elevation length, which is always a horizontal line from A dash. Another name of top view is plan length, which is always a horizontal line from A. Now very important, on the locus of B dash, compulsory 2 points must lie, that is B dash, B1 dash. Similarly, on the locus of B, 2 points which should compulsory lie is B dash, sorry, this is not B dash, this is B and B2. Okay, so on the locus of B, the 2 points which should compulsory lie is B and B2, and on B dash locus it is B dash and B1 dash. Finally, when you merge both the diagram, this A dash and A dash will coincide, A and A will coincide, and as per orthographic, front view and top view of a line or a point or an object always lies on the same line. So you should remember that after you merge both the objects, this front view A dash B dash and AB lies on the same vertical line. So this left side light vertical line is called as projector of A, and on this vertical line 2 points which will compulsory lie is A dash and A. This line is called as projector of B, and 2 points which will compulsory lie is B dash and B. And also you should know that this horizontal gap between both the projectors is called as distance between end projectors. Okay, so as per ortho, front view and top view must lie on the same vertical level. Finally, when you start with the numericals, or you can say word problems, the quality of drawing should be like this. Front view and top view should be dark. You have to double trace and draw front view and top view dark as per the knowledge of orthographic. The actual object, that is a line which never exists before the drawing, it only exists after the drawing is prepared. So this red lines which is shown should be drawn medium dark. So you are supposed to draw by pencil only, but the shade should be front view, top view is always dark, true length is medium dark, rest all the lines are light. So I given the abbreviation besides. The black line in the diagram is dark, red is medium dark, blue or green is always light. Okay, so these are the various notations what you have to remember. And finally this one, in first quadrant, front view is always above and top view is always below. So dash is above and without dash is below. In second quadrant, both front view and top view are above xy. Third quadrant is opposite of first. In third quadrant, top view is above and front view is below. So without dash is above and with dash is below. And finally fourth is opposite of second. So in second, both front view and top view are above xy, but in fourth, both front view and top view are below xy. So these are the position of the points in various quadrant, what you should know before we start. Okay, so let us start with question number 1. So this is the first word problem what we are starting with. So what you should do in the examination is, suppose if this question comes in the exam and if I want to attend, so suppose it is question number 1, with pen you should always write question 1. So either blue or black in the exam, you should write question 1 like this. Okay, next step is this word problem you need to convert into useful data. As I told you, in projection of lines, total there are 12 datas. Remember 12. 4 positional, 4 linear, 4 angular. Out of 12, 5 datas will be given to you. Not more than 5, not less than 5. You need to play with this 5 data and get the remaining. So how will you start? Let us see. So suppose I am supposed to answer the question here. So step number 1, what I should do is, on the left side, besides question number 1, you should write in capitals with pencil, okay, with pencil, data, and underline this. So let us start reading the question. The distance between the end projectors of a straight line AB is 35. So they have clearly said there is a line AB and the distance between their projectors is 35. So our first data, what you should write is dBp. So you should write in capitals and then write equal to, and you should write 35. No need to write the units millimeter because entire engineering graphics is in millimeter. Now second data, the endpoint A is 10 millimeter above HP, also called as HRP. The long form is horizontal reference plane, and 20 millimeter in front of VP. The long form is front means what you can see in the front reference plane. So these are the other names of HP and VP. HP stands for HRP, VP stands for front reference plane. So if a point is 10 above HP, so you need to understand the points what you've done before. A point is 10 above HP and 20 millimeter in front of VP. So how will that point look like? So let us see here. So suppose this is VP and HP, and let me draw VP and HP. These are the four quadrants. Okay. So now what they've said, point A is 10 above HP and 20 millimeter in front of VP. So anything above HP, so this is HP and this is VP. So if a point is above and in front, it means it lies in the first quadrant. So point A is here. Okay, let this be point A. So point A is 10 above. So this is 10 and 20 in front. So this is 20 in front. Okay, so point A is 10 above. So this dimension is 10 and 20 in front. So this dimension is 20. So when you look in the front view from this side, the projection of point A falls here, called as A dash. And if point A is 10 above, it means the projector from XY is also 10 because they are parallel. If a point is 20 in front, see anything in front you have to look from the top. You cannot make out from the front. So anything in front is seen in the top view. So projection of point A will fall on HP, called as small a without dash. And because this is 20 in front, parallel to this, even this will be 20. Okay, so now if I remove the actual object and you left only with the image A dash and A, so this is the image A dash and A, and if you turn HP down, what will happen is A dash will remain up by 10 from XY and A will go down by 10 from XY. So I hope the concept about point A is clear. So how we should write this data? So remember, A dash is 10 above and A is 20 below XY after you turn HP. So what you have to remember is, in the question they will give you the data in terms of HP and VP, but while answering you have to convert them with respect to XY. So you should write like this: A dash. I am discussing the standard format. You have to follow the same. So A dash equal to 10. You have to show the arrow mark what we have practiced here and write XY. So once again, 10 above HP in the question should be converted in terms of XY like this. No other format will be accepted. After that, small a is 20 below XY. Okay. Or you need to by heart like this: anything in front will be below. Anything behind, after you turn, what will happen? Suppose a point is behind, after you turn, this will go above. So anything behind will be below XY. Pardon. So anything in front will be below XY, and anything behind will be above XY. So that is about point A. Let us read the question further. The end point B is 45 above HP and 70 in front of VP. So you need to visualize, if a point is above HP and in front of VP, so in which quadrant it lies? Above, in front. So it is again in the first quadrant. So point B is 45 above and 70 in front. So let us discuss here. So in exam you should not draw all these diagrams. This is only for your reference. So if you're smart enough, without the diagram you should be able to understand. So let us see. Point B is 40 in front. So when you look in the front view, this point will be B dash. And when you look at the top view of B, the projection falls here, called as B without dash. Now they are saying point B is 45 above HP. It means the distance of B dash from XY is 45. And it is 70 in front of VP. So this dimension is 70 in front of XY. So when you turn HP down, B dash will remain up by 45 from XY, and 70 will, and B will go down by 70 from XY. Okay, so here we have B. So where is B dash? 45 by XY, and B is 70 below XY. So the next data what we should write here is B dash equal to 45 above XY, and B is 70 below XY. Okay. Finally, let us read the question further. Draw projections. What do you mean by draw projections? So all of you have to make a note. Draw projection means you have to draw front view and top view of the line. That is the meaning. So in orthographic, when we used to see an object, we used to project and draw in our paper. So we used to draw what? Front view, top view and side view. Similarly, draw projection means you should draw front view and top view of the line. And now important, determine its inclination with HP and VP. When I say its inclination, so you should know it is inclination of the line. And line means which line? It is the true length. So you have to read the question like this and determine the true length inclination with HP and VP. So what is the notation for inclination of a line with HP called as theta, and inclination of line with VP is called as phi. So you're supposed to find theta and phi. So you can put theta question mark, phi question mark. Okay, and finally they have asked also find its true length. So you have to also find the true length. So if you try to look at the 3D of the diagram, they have given us DBP is 35. So we know that the distance between projector of A and B, this gap is 35. So DBP is given as 35. This is the first data. Then they are given position of A dash 10 and position of A is 20 from XY. B dash is 45 and B is 70. So if you count 1, 2, 3, 4, 5, total 5 data are given. Okay, so first, second, third, fourth and fifth. So you are asked to find true length. So just I will brush up the concepts here. So what we can do with this data is, from B dash can we draw a horizontal line, and we can write this as locus of B dash, isn't it? So this we know that B dash lies on locus of B dash. Then from point B, if you draw a light line, this can be written as locus of B. Further, if I join A dash with B dash dark, we'll get front view of the line. It should be drawn dark. If I draw A with B dark, we get top view of the line. Now you are asked to find true length of the line. You are asked to find true length of a line. Okay. So for that you need to use this tool. So if you look at this tool, if you have, consider any one of the tool. If you have top view, rotate till the level of A. So this is the top view. We can rotate this till the level of A, isn't it? So I will rotate top view to the level of A. I'll get a point here. Now this point, if I project to cut the locus of B dash, I will get B1 dash. So project this point to cut the locus of B dash, and here you will get B1 dash. So this should be drawn light. Finally, if I join A dash with B1 dash, I will get the true length. So if you join A dash with B1 dash, you will get the true length here. So if you rotate top view of a line and project, you will get true length in the next view. So that is how you can find true length. Now we know that true length in the front view is called theta. So this angle theta you can come to know. Okay, so this is just a 3D diagram. Let us see the actual answer what we're supposed to present. Okay, now to begin with the numerical. Suppose the question carries 10 marks. So step number 1, align the roller scale with the edge of the paper. Roll it, and below the data what you have written, just below the data what you have written, you have to draw a medium dark XY line, medium dark. Okay, don't forget to write capital X and Y as I have told. So in the examination, if a student forgets to write X and Y, so half mark will be deducted each. Half mark will be deducted for not writing X, another half for not writing Y. So XY is the first thing what you should start with. Next thing you should remember is anything above XY. So up till now all of you understood that the line is in the first quadrant, isn't it? So you have understood that. So the position of A is given in front and above, B is also in front and above, it means A and B both are in the first quadrant, and if we join A with B, this is the true length of the line. So it is understood that the line is in the first quadrant. Okay. So first you should draw a medium dark XY line. Next step, you should always plot these data first. So DBP is a linear data. The rest 4 are positional data. So out of these data, the 5 data, the step is that you should always mark the position data first. So the name of the line is AB. You first of all decide which point will you keep fixed and which point will be rotating, because in lines, out of the 2 endpoints, one point should be fixed and other should be in a rotating mode. So let us always take the starting point A as the fixed point and the moving point be B. And the concept should be thorough that locus is available only for the moving line. Fixed point will never have a locus. So our next job is to mark A dash and A on the same projector, which is 10 and 20. So we know that as per the tool, A dash and A always lies on the same vertical line. Okay, so we'll mark A dash 10 above and A 20 below on a light projector. So next step is perpendicular to XY. So if you look at the scale, this any one of the number like 6, you can see line at 6. So you can align 6 with this XY line, or you can roll parallel to the edge of the paper. Okay, we can roll parallel to the edge of the paper and draw a light line. Now where is A dash as per the data? Okay, so A dash is 10 above XY. So mark a point 10 above. And where is A? 20 below XY. So mark a point 20 below XY. So we need to mark 2 points. So don't be in a hurry. We need to understand each and everything before we proceed with. So after mark 2 points, on the left side and above, see left side and above, neatly write A dash. On the left side and below, write A. Once you have written A dash and A, you should show the dimensions, because dimension carries marks. So leave a small gap from the point, draw extension line up and down, and then parallel to this projector, roll back, draw a vertical line and show the same arrowheads what you practiced in orthographic. Length 3, height 1, and write above the line. This is called above the line, 10 and 20. So the point A dash is 10 above and A is 20 below. This is the way to mark position data. So after that, the next position data is B dash and B. So B dash is 45 above and B is 70 below. Okay, so we know as per the tool that if B dash is 45 above, it means the distance of B dash from XY is 45 and the distance of B is 70 below from XY. But if you look at this data, right now I'm not very much sure that if I move 45 above, where exactly B dash will lie. It can be make out later on from DBP, but suppose if I have not plotted DBP right now, then I'm not sure where will B dash lie. But I know that B dash will lie somewhere above XY, that is 45 above XY, it will lie somewhere on the line. So instead of trying to find out right now where exactly B dash will lie, why not draw a light line locus which is 45 above, because we are sure that B dash will lie somewhere on the locus. Similarly, B is 70 below. So if you come down by 70, B lies somewhere here at 70 millimeter below on a locus. So what we are going to do next is, from XY we will mark 45 above. Okay, to 10, 20, 30, 40, 45 above. Okay, so let me get it little down. Okay, so we have moved 45 above. Okay, once again 10, 20, 30, 40, 45 above, and we have to move 70 down. Okay, so let us move 70 down. So from here 10, 20, 30, 40, 50, 60, 70. So please remember these 2 points what I have marked, 45 and 70, it should be measured from XY. By mistake what student does is they measure from A. So by mistake students mark 70 from A and 45 from A dash. So they will get a wrong answer. So you should be aware of this. Okay, after this, we know that on this vertical projector, 2 points B dash and B should lie. Where should B dash lie? So in the question they have mentioned that B dash is above x5. So we know that B dash will lie somewhere on this locus and at the intersection of this DBP. So before we mark B dash, one important dimension we need to give. So all linear dimensions you have to show. Linear means straight line dimensions. So here we need to show one dimension. So we can draw the dimension over here and we can write DBP. We can write DBP like this, equal to 35. So this is the way to show DBP. Write DBP equal to 35. So half to 1 mark will be deducted for not showing the dimensions. So you should be very careful. So to always show straight line dimensions, I am very clear. Either horizontal or vertical dimensions, if any, you have to show. If there are any inclined dimensions that you need not show, so only vertical and horizontal dimension you have to show in this topic. Next step, so we know that wherever locus of B dash and DBP intersects, that point is B dash. And wherever on the same projector, wherever this projector intersects locus of B, that point is B without dash. So once B dash and B is being plotted, we should know that B dash, as per the tool, B dash should always be joined with A dash, and that is called as front view. A should always be joined with B, and that is called as top view of the line. So let us join this A dash and B dash. And what about the nature of the line, light, dark or medium dark? So yes, front view and top view is always drawn dark. So you have to double trace A dash, B dash and make this darker. And even here, we need to double trace A and B and draw this dark. Okay, so remember double trace is important to make a line darker. Now above the line and along the line, write FV. So this is the front view of the line. Even here above the line and along the line, write TV. So standard way to write, you should not deviate from this. So this is called as plotting the data. So out of 10 marks, you deserve 2 marks, only 2 marks for plotting this data correctly. Okay, so if you don't show dimension, then -1. If you don't write x, -half, y -half. So you'll go into negative marking if you're not thorough with this. Okay, so after the data is plotted, our objective is to find theta, phi and true length. That is our objective. So now how we should go about? So what one can do, out of front view and top view, you select any one tool. You select any one tool. So let us select tool number 2. So see, front view is given as A dash, B dash. Now you should know how to operate the front view. So what you should remember, whenever front view or top view is given, you need to rotate till the level of A dash. So if front view is given, rotate till the level of A dash, and if you have top view, rotate till the level of A. So you have to make use of these tools. So A dash, B dash, front view we have with us. So you can rotate this till the level of A dash. You will get elevation length and B2 dash. Then project B2 dash to cut the locus of B. You will get B2. Join B2 with A to get the true length. Okay, so this tool we need to use it over here. So the only thing is that this tool you have to copy from here to here. This is the only thing what you have to do. So let us see now. So A dash, B dash we have with us. Even here you have A dash, B dash. To rotate front view, but you should know till where. So you should rotate till the level of A dash. So in the compass, and what about the nature of the curve? It should be light. So in the compass, keep your needle at A dash, because A dash is a fixed point and B is a moving point, and the pencil should be at B dash, right? So once you've done this, you need to rotate this light, but till where? Till the level of A dash. So in the exam, while supervision, I have seen that students don't know where to stop. They just go on drawing the circle. They don't know where to stop. So you should know where you're supposed to stop. Okay, so let us draw level of A dash first. So align the roller scale with XY, slide it above. Okay, So this point we have located, that is as per the tool it is B2 dash, and this line is called elevation length. So you are supposed to label this as B2 dash. So what I am showing here, the same format you have to follow, and this horizontal line is called EL. So write EL elevation length here. Now once that is done, this is called operating half tool, and by operating half tool you won't get the answer. So the next part of the tool is, once you reach B2 dash, you should not stop here. You need to project B2 dash. You need to project B2 dash to cut the locus of B. So whenever you practice tools, you have to say correctly. You should not say project B2 dash down. The correct statement is project B2 dash to cut the locus of B, because that will be helpful in the next numericals. Okay, so where you need to project B2 dash to cut the locus of B. So B2 dash is here and locus of B is down. So I'll align the roller scale with this, roll it and draw light line. So even this line should be light. So wherever this B2 dash cuts the locus of B, this point as per the tool is B2. So we should name this as B2. Now this B2 should be joined with A. So but nature of the line is medium dark. So join A with B2 medium dark. So there should be difference between both the lines, a slight difference. So above the line and along the line, name this as true length. So that is how true length is ready. But this true length is in the top view or front view? Yes, it is in the top view. So this angle is 5. That is what they've asked, 5. So they've asked us to find 5. They've asked us to find true length. And they've also asked theta now. They've also asked theta. So what is theta? So theta is the angle made by, so let us see the next tool. So theta is the angle made by true length with HP. How will you get this now? So one may operate the next tool, that is, if you have top view, rotate top view till level of A. So if a student can rotate top view till level of A, he or she will get the plan length. Now if I project the plan length to cut the locus of B dash, so after you get the plan length, cut the locus of B dash and join with A dash, you will get the next true length, and also you will get theta. But we will not do this. Why? Because if you are operating the next tool, it means you are not thorough with the concept of lines. So what is that we have to learn is, we need to understand that, suppose this pencil is a line, correct? If the line is inclined to HP like this with the paper, you can see right now on your screen apparent length of the pencil, correct? Suppose this pencil is 100 millimeter long. The pencil is 100 millimeter long, suppose. And if I want to see true length at this condition, what I will do is I will rotate this. So see, length has increased, further increased. Now this is the maximum length. So this length is going to remain 100. Suppose now if the pencil is inclined to VP, assume that there is VP behind, there is a plane behind, and the pencil is inclined to VP. Can you make out? So in the front view you can see apparent length. If I want to see true length, I will rotate again. Now the length is slightly increased in the front view and it is maximum when it reaches here. So in the front view also this length will remain 100. So the conclusion is, given a line, its length is not going to change. Its true length is not going to change in front view or top view. The true length is going to remain same. So the concept over here is, the length of this line A dash B1 dash has to be equal to the length of the line AB2. Not in the tool, because in the tool you have not taken any measurements. It is drawn randomly. But in any word problem of lines, the true length will remain same because of this concept that a line, if you intend like this and take a turn, it will show 100. If you intend like this and take a turn, then also it will show 100. So the length of the line will not change in any of the view. So therefore, we will not follow the concept of rotating the tool again. Then what we should do? So because we have got one true length AB2, and we know that the next true length has to be A dash B1 dash. The next true length has to be A dash B1 dash. So and both the true lengths should measure same. Okay, so where does B1 dash lies? It lies on the locus of B dash. So here locus of B dash, one point is missing, that is B1 dash, and that has to be connected with A dash. So the true length remains same. So smart work is, why not take A B2 in the compass? Why not take A between the compass? So the true length remains same. Now keep the compass needle at A dash and cut an arc on the locus of B dash, because this length has to be equal to the other length. So this point what you're going to get here, the new point, that is B1 dash. So this smart work all of you have to use in the exam also. Then join A dash with B1 dash, medium dark, and write TL true length above and along the line. Okay. The last part what is left is, whether they have asked or not in the exam, you have to indicate all the four angles. You have to name all the four angles. So A dash B1 dash is always theta. So A dash B, oh okay, I forgot to tell you. If you observe all the four angles, theta, phi, alpha, beta, all these angles are with respect to horizontal lines. Are with respect to horizontal lines, out of which theta and phi is with HP and VP, alpha and beta is with XY. So here EL is our horizontal line. So small angle should be shown first, because in ortho we have learned always show smaller dimension first. So this true length with horizontal is theta. So theta angle is smaller and alpha is larger. So theta and alpha are best friends. You can see them always in the front. So look at the tool. Theta and alpha above XY is front view, isn't it? So theta and alpha is always seen from the front. Phi and beta is always seen in the top view. So here we need to draw a light horizontal line. Okay, and here the smaller angle needs to be shown first. So you are supposed to only indicate the angles. Do not write the value. Don't write theta 30 or whatever it is. So here only indicate the angle, that this is called as 5. An angle made by top view with xy or horizontal is called as beta. So you should indicate all the four angles in all the questions, whether they've asked or not. Yeah, once this is done, the last part is, they've asked you to find out the values of these three things, theta, phi and true length. So let us take a protractor and measure theta. So if I measure theta, I am getting okay. So if I keep this protractor here, and if you measure theta, I am getting approximately 30 degree. So theta is 30 what I am getting. Then they ask you to measure 5. So keep your protractor below like this. And if you measure 5, 10, 20, 30, 40, it's around 44 or 45. Okay. They also asked you to find the true length. So if you need to keep your scale here. Okay, so let us align the scale. So true length is how much it is? Yeah, approximately 70 millimeters, 70. So true length is 70. Okay, so this length is 70. Don't write 7 by mistake, otherwise it will be considered 7 millimeter. So it is 70 millimeter. Now where we should write all this data, let us see. Okay. So in the projection of lines topic, the right place to project your answers is by pencil and below locus of B. So what you should do here is write theta 30 and degree above, write 5 45 and degree above. True length, you need not write millimeter, because we know that entire graphic is in millimeter, so only 70 is sufficient. By mistake if you write 7, you are out. Next, this you need to enclose neatly in a box by pencil only, and you should write here ANS, answer. So compulsory for all the numericals below locus of B, you have to present the answer like this, theta, 5 and true length. Clear? So that is how the entire answer needs to be presented. So you can have a look at this. Okay. So on top, data, write the data, plot your answer. Top view, front view should be dark, true length medium dark, and the final answer you need to put inside the box neatly like this. Okay. Now the doubt is, before I proceed on, the doubt is, in the tool plan length is also there, B1 is also there. So the concept is like this: you should name only those points which you have rotated and projected. So here I have rotated front view, so it's compulsory to name EL and B2 dash. I have not made use of the next tool. I have not rotated top view to get the plan length, so no need to write PL and the corresponding point. So only those points should be labeled which you have used to get the true length. So let us switch on to question number 2. Here the question is, the top view of a line AB measures 60 millimeter. The top view of a line AB measures 60 millimeter. So you have to understand whether this 60 millimeter is the true length, or front view length, or top view length. So it is clearly mentioned top view of a line AB measures 60 mm. Okay, so as per the tool, if you look at this tool what we have done, so it is said that the top view of a line AB measures 60. So it is the top view length AB which is 60 and not the true length. So our first data is top view equal to 60 millimeter and makes an angle of 60 degree with x5. We know that true length always makes angle with HP or VP, but alpha or beta, which is the front view or top view, always makes angle with x5. So 60 degree with x5 cannot be theta or 5, because theta is always with HP and phi is always with VP. So if we read together, the top view of a line AB measures 60 millimeter and makes 60 degree with xy. So again, looking at the tool, the top view of a line AB measures 60 millimeter and makes, so this line makes 60 degree with xy. So top view is always with xy, we know that. So this angle is beta. So they are given beta 60 degree and top view length as 60 degree. Okay, so let us write down here the data. So first, as we discussed last time, always write question number with pen, and then with pencil you have to start writing the data. So by capital you should write data, underline it. So they have said top view length, so you may write TV. So TV alone is sufficient, no need to write AB. So TV equal to 60 millimeter. Also no need to write millimeter. So top view of a line AB measures 60 mm and makes an angle of 60 degree with x5. So I hope all of you are able to see the question. The top view of a line AB measures 60 millimeter and makes 60 degree with x5 line. So this angle 60 degree is nothing but beta. So we'll write beta equal to 60 degree. So this is our second data. So out of 12, total data what will be given is 5. So that we are aware of. Okay, next let us proceed. So point A is on HP and 20 millimeter in front of VP. So where is point A? On HP and 20 millimeter in front of VP. So let us try to draw here. So if I draw the 4 quadrants, so these are the 4 quadrants and this is the XY line. So what they said, point A is on HP. Okay, so let us read. The point A is on HP and 20 millimeter in front of VP. So point capital A is on HP. So on HP means it can be here or here, but it is 20 millimeter in front of VP. So this is our VP and this is our HP. So point is 20 millimeter in front of VP. It means capital A is neither above HP nor below. It is on HP. And 20 millimeter in front means the distance from XY, this is 20. Okay. So now carefully look in the front view from here. The projection of point A falls on XY, called as small a with a dash. Whereas if you look from top view, the same point is small a without dash. So we are not very much sure where the point lies, on first quadrant or in the fourth quadrant. So but here it is assumed that point lies on both the quadrant. And now turn this HP down. What will happen is A dash will remain on XY and A will go down by 20 millimeter. So we need to write the data here. So how will you write? Okay, so refer this diagram. So we should write that A dash. See, A dash is on xy, no? Neither above nor below. So you should write here A dash on xy. You should write on xy like this. Standard way to write. And what about small a? It is below xy. So in question they will give you with respect to HP and VP, but while answering you have to specify with respect to xy. So point A is 20 below xy. So you should write A equal to 20 below xy. So let us proceed with the question further. Now they have said draw the projections of line AB. So once again let me remind you, draw the projection means you have to draw front view and top view of the line. If the line is inclined at 32 HP. So again, whenever a line is inclined with HP, it means that angle is theta. With VP it is 5. With xy it is alpha or beta. So here line inclined with HP is theta. So theta is 30 degree. And what they've asked you to find the inclination of the line with VP. So how to read this? Inclination of line means true length. So they are asking you to find the true length of the line, angle made by true length of the line with VP. So they are asking you 5. So theta is given as 30 and 5 they were asking. So theta is 30 degree. Theta is 30 degree and we are supposed to find out 5. So if you count the data 1, 2, 3, 4, 5. So 5 data is already given. Okay, to begin with now, all of you will first draw a medium dark xy line. So the previous question xy what you have drawn, try to align with the same xy and draw a medium dark xy like this. Okay, so I think we need to draw a bit above. Okay, so it's fine. We'll see next time. So let us draw xy here. So in continuation with the previous question xy, you can draw one medium dark xy, write xy in the center. Now let us read the data. So it said that out of this 5 data, which data you should always mark first. So as discussed in the previous question, this is linear data top view, this is angular data, and both these are positional data. So always mark position data first and then you have angular data. So the concept is always you should mark the position data first. So let us align the roller with this line. Just move it out and draw a light line. Okay, so I will zoom a bit. Okay, so after the light line is drawn, it is said A dash on xy. Okay, so here is mentioned A dash on xy. So wherever the xy intersects the projector, name that point as A dash. So write A dash above and on the left side. Now the next position data is A equal to 20 below xy. So we need to come down by 20 from xy. So from xy, we will come down by 20 and mark a point. So this point you should write where? You should write on the left side and below. So write A neatly here. Next step is dimensioning, don't forget. So from here, roll it down, leave gap of 2 millimeter, extension line, and from here neatly show dimension 20. So the only fundamental of line is always mark position data first, as you can see here. So you might get 1 mark if the examiner wish to for marking the position data correctly. Okay, after A dash and A is done, now they have not mentioned anything about B. Where is point B? So here comes a new concept what you have to learn. The thing is like this. So in projection of lines chapter, this is our vertical plane. Correct, this is our vertical plane and this is horizontal plane. So the speciality of this chapter is, because all these planes are imaginary, now suppose if a point A lies on HP, as in this case, so it is not like that if A is on HP, then point B, sorry, if A is assumed to be in the first quadrant, then B will also be in the first quadrant. It's not like that. It is also possible that if A is in first quadrant, the line may cut the quadrant, come out from the other side, and B can be in second quadrant also. So if A is in first quadrant, it is not compulsory that B will also be in first quadrant. B can be in second quadrant also. Even B can be in third quadrant. It will cut the quadrant, come out from here, and B can be in third quadrant also. And finally B can be in fourth also. So whenever they are not mentioned about the other endpoint, here they are mentioned about A clearly, it is on HPN 20 in front, but they are nowhere mentioned about point B, whether it is in first quadrant, second quadrant, third quadrant or fourth quadrant. So all these possibilities exist in this topic. So what we need to learn is, whenever in the question they do not mention about B or there is no information about B, so for our simplicity, always assume B in the first quadrant. Always assume B in the first quadrant. So what you should do over here is, this data what you have written, okay, so at the end you should write like this. Now tell me, if B lies in first quadrant, where should be B dash, small b dash, and where should be B? So we know that in first quadrant front view is above, so B dash is where? Above x5. How much above we don't know. And what about B without dash? That is below x5. How much below we don't know. So you should put a flower bracket and write down like this: assume capital B in the first quadrant. So you have to write down like this in the exam also. Okay. So this part is clear. So here we are assuming that B is in the first quadrant. So B dash will be above xy and B will be below xy. Now proceed on to the next part. So next part. Well, next part. So we have marked A dash, we have marked A. Now top view and beta goes together. Top view and beta goes together. It means always whenever you mark top view, it is marked on angle beta only. And look at this tool, top view always starts from A and top view is drawn towards locus of B. Remember that top view is always drawn towards locus of B and it makes beta. So in our case, A is here. Can you make out? What about locus of B or B? Will it be above or below? Yes, so I'll just write down B over here. So B is over here and B dash is somewhere above. So we know that beta, angle beta is always drawn towards locus of B or is drawn to cut the locus of B. So beta is given 60 degree, top view is given 60. So very simple, from point A with respect to horizontal, draw 60 degree. So first of all, let me draw a light horizontal line. Let me draw a light horizontal line. Okay. Now with respect to this horizontal, I need to come down by 60 degree and then mark 60 millimeter on it. So here I'll keep the protractor, and from here you need to count 60 to 10, 20, 30, 40, 50, 60. So 60 degrees here. You need to mark 60 like this. Once 60 is being marked, you need to draw light line. Correct? So first we'll draw light line. Okay, now we are supposed to mark the top view length 60 on it. So angle, this angle was beta, we will name it later on, and we need to mark top view length 60. So if I want to mark 60 millimeter on this, I have seen there are two types of students. What they do, they take their compass, they set 60 and then they cut. Okay, but smart work, what is smart work? So smart work is straight away take a scale, you don't need a compass, and mark 60 directly on that line. This is smart work. So what is the nature of this top view line? Is it light dark or medium dark? Yes, so top view is always dark. So double trace, and above the line, along the line, you should write top view like this, and this point is B without dash. Can you guess, once you get B from the tool, will you be able to draw any line? So once you get B, we should be able to draw locus of B, isn't it? So that is how we get locus of B from here. Okay, so I will erase this a little. So now we are getting locus of B. So let us roll down. So from here I will roll down, draw a light line. Locus is always light, and you should write on this with capitals. Locus of should be capital and B should be small. So locus of B is ready. So have we plotted all the 5 datas? Answer is no. We have plotted top view, beta, A dash, A, theta is left. So theta is the angle made by true length with HP. So go back to the tool. See, tool is very useful. So if we want to mark theta, so for theta you need A dash because theta always starts from A dash. If a student bias like this, theta is always drawn above, then he will not learn lines. What he should say, draw theta to cut locus of B dash. Where he should draw theta? To cut locus of B dash. So theta should start from A dash. Do we have A dash? Yes, we have. Where is B dash? It is above. So theta should be drawn to cut locus of B dash. How much is theta in the question? 30 degree. Take out a protractor and mark 10, 20, 30 degree here. But again, if you refer the tool, see on theta always true length is marked. Have you noticed this? On alpha always front view length is marked. On beta always top view length is marked. And on 5 again true length is marked, and both these true length are equal. We have seen in the last example. So now on theta we should mark true length, but a suspense, or you can say something what is missing is true length is not given. Okay, let us see later on. Let us at least mark theta 30 degree. So we this point is 30 degree. So we will first of all erase this B dash. We know it is above. Now from A dash we will draw a light line in the upward direction like this. So this angle is theta. No need to name now. We'll name it at the end. So as I told you, only linear dimensions, straight line dimensions, horizontal, vertical dimensions should be given. Angular dimension, if you don't show, it's okay. So on this theta, true length should be marked, and that is not given. So 1, 2, 3, 4, 5 datas are done. We are done with 5 datas. We have plotted all 5. Now what is the objective? You have to find out 5. So if you look at the question, you are asked to find 5. So now it's time to make use of the tool. Yes, think over it. Okay, let's compare. We have top view here, top view here also. It is on angle beta. Okay, this is beta. B lies on locus of B. Everything is there. But the only thing what we don't have is locus of B dash, because if I rotate top view till level of A and if I project, it should cut locus of B dash. But here the thing is, if I rotate this top view till level of A and if I project, I don't have locus of B dash. So what can be done? So look at this tool from another angle. If you don't have locus of B dash, no problem. Tool says take top view, rotate till level of A, and if you don't have locus of B dash, at least project this so as to intersect angle theta. So wherever this theta angle and this projector intersects, that itself is B1 dash, and once you get B1 dash, you can draw locus of B dash. So there are multiple ways to look at a tool. So what I said, rotate top view till level of A, project to cut theta. Can we do this here? See, this angle is theta. Let me write down light. You are not supposed to write this. And this angle is beta. So see, you have both theta and beta. So if you have top view, rotate, project to cut theta. If you have top view, rotate, project to cut theta. Yes, very simple. Yes, you got it. So let's start. So we'll take this top view in the compass. Okay, so I hope all of you can see. Yes, rotate this how much? Till the level of, the correct word what you to use is level of A. Once you get this level, name this line. So this line is called as plan length, PL. So name this as PL. Okay, name the point B1. So this point is called as B1. Further project B1 to cut angle theta. So parallel to this projector A-A, roll and project to cut angle to intersect theta. Wherever both the lines intersect, that point as per the tool is B1 dash. And B1 dash should be joined with A dash medium dark. So this point is B1 dash. So join B1 dash with A dash medium dark, you will get the true length. So just slightly you need to darken it, not much. So I've done that. This is the true length, right true length above the line, along the line. Okay, again, once you get B1 dash, we can easily draw locus of B dash passing through B1 dash. So keeping the scale in contact with XY and moving up, we can draw a light line, and don't forget to write immediately above the line as locus, LOCUS, locus of B dash. Okay, so okay, we have done. Now what they've asked, 5. They've asked you to find out angle 5. So what is 5 as per the tool? So 5 is the angle made by true length with vertical plane. So we need to get one more true length. Okay, so as we studied before, true length will never change. True length remains same. So this, once you get one of the true length, I can take the same length in the compass, and to get the next true length, which is AB2, and B2 lies on the locus of B, and locus of B we have with us. So from A, if I cut the same true length, I will get AB2. Let's do that. So I will take this true length in the compass from A dash to B1 dash, and from point A, I'll cut an arc down. So wherever this point intersects the locus of B, that point is B2 as per the tool. Okay, and then join B2 with A to get the true length, and that should be medium dark. Okay, so I will join this medium dark with B2, and I'll write TL above the line, along the line. But this is not the end of the question. Again, if you look at the given question, they have asked you to draw the projections. See this. What do you mean by draw projection? You have to draw front view and top view of the line. So if you measure AB2 with horizontal, which angle will you get? If you measure AB2 with horizontal. So if you measure AB2 with horizontal, you are going to get 5. So 5 is ready. That is what they've asked, 5. But they have also asked you to draw projections. So draw projection means draw top view and front view. So see, top view is already ready. How will you get front view? Yeah. So anything we can get from the tool? Yeah, so what we can get from the tool? So one of you might think in opposite direction. See, we have AB2, right? Even AB2 is here. So this was your home, B dash was your home, and B2 was our college, our institute at Somaya Sign. So from B dash, if you know the way, rotate, project, from home, if you know how to reach college, you should also know the reverse way from college to home. So the path will never change. So if you go reverse way, what have you understood? If you have true length, don't rotate, project. So first project, how much you do project? Till level of A dash. So if you have AB2, project till level of A dash, and A dash is here. What will you get? Elevation length. Once you get elevation length, if I rotate to cut locus of B dash, will I get B dash? So once you have elevation length, you can take in the compass and rotate. So wherever it cuts the locus of B dash, you're going to get B dash. That's what we need. So join B dash, A dash. So what I want to say is, if you know the tool to operate from front view to true length or from top view to true length, you should also know the same tool how to, if or else what I can say, if true length is given and if you want to find top view, how to find. So whenever true length is given, project first, then rotate. Whenever top view is given, rotate first, then project. So this in and out story of these tools, you should know how to use it. But I will not follow such a long cut method. Project true length till level of A dash, write EL, write B2 dash, then rotate, B dash, join. Do you have any shortcut method? Yes, orthographic. So what has orthographic taught us? It has taught us that this thing. It has taught us that if you have top view, because A dash and A are in the same level, and if you project B, you will get B dash, because orthographic has taught us that front view and top view are always on the same line. So remember, after you drawn one of the views, we used to project in the next view and then complete the other view. Same story here. You know top view now. You know A level is A dash. So B has to be B dash. So follow the same concept here. A is already projected to get A dash. Can we project B straight to cut the locus of B dash? That is how you can get directly. So whenever top view is given, remember front view should lie on the same level because of ortho concept. So here align this, move and extend, project this B. So A projection is A dash, B projection has to be B dash, which should lie on the locus of B dash. So always on the locus of B dash 2 points should lie, B dash, B1 dash. Always on the locus of B 2 points should lie, B, B2. Once you get B dash, join A dash with B dash dark, double trace and draw it dark. Slightly it has gone out. After I drawn this dark, above the line, along the line, write FV, means front view. So that is how this is called draw projections. Last but not the least, show angular. Show means you have to specify the angles. So this is theta, do not write the value. This angle is alpha, theta and alpha best friends, always together. Inner angle is 5, what they've asked you to find. And the outer angle is beta. So in the question what they've asked, measure angle 5. So let us align the protractor with this 0. So 10, 20, 30, 40, 49, approximately 49 or 50 it is. Okay. So here below the locus of B, you should write the value as phi is equal to 49 or 50 degree, whatever you're getting. So let me discuss about the error. In the examination, plus minus 2 degree error is allowed. And if true length is asked, so for linear dimensions, plus minus 3 millimeter error is allowed. But for angular dimensions, plus minus 2 degree error is allowed. So instead of 50, if a student gets 48 or 52, everything is acceptable. Okay. So if you compare both the questions what we have solved in front of you, look wise they are identical, but the datas are different, this is different. And from where did you get this diagram from? So if you look at both our tools and if you merge both the diagrams, try to merge both the diagrams. So this A dash B dash will come somewhere here, this true length will move out. So when you merge both the diagrams, this is the result what you will get, or this is the result what you will get. So you have to always draw merged diagrams. So why we have separated? We have separated so that you can understand them easily and you can operate them. Clear?